we'll go forward. Right. So yesterday we were discussing about select query, right? So how select query works. So this is a typical query life cycle in so in terms of select statement, right? Let's say you have so select query that you are executing. So this is a typical so architecture or a query life cycle, like how it goes through and get the result set. So initially, so I have not mentioned any network, so SNI packet or network interface, TDS packets and all. So this is a basic query cycle. So just a moment, let me put all together here. So yeah, so you ran a select query. So it initially go for parsing, right? Parsing is we discussed, it is a validation of syntax, syntactical so validation, syntax validation. So then it go for binding is nothing but a schema binding. And so metadata is nothing but so defines the data. So in simple words, for example, let's say your name. So name is ABC, right? So if you mention ABC, so we don't know what is that ABC. So you should have to define the name. So name is called a metadata. So it defines a data, right? So we call it as a metadata. So it is binding that so data types, data schema binding, and everything. So it is also called as algebraizer, right? So once this is done, then it will create a query tree. So query tree, I told you, right? So it is a so it is a kind of normalizing the query into multiple segments, and it will pass to the query optimizer, right? Query optimizer is the so heart where it creates a plan for the query uh, by searching multiple so optimization levels, right? So if it is what is trivial plan, so if it is a simple query, let's say select star from table, so without any joins, without any so complexity, if you execute that select star from table, so we call that as a trivial plan, right? So then if it is not trivial, right, so we call it as a full optimization plan, right? What is full optimization plan? So let's say, for example, we have some joins, or we it is using some indexes, or it is going for parallelism. So all these searches, we call it as a full optimization. I'll show you that how it looks like by executing a query, right? So that you will understand in a better way, right? So it keep on so within fraction of seconds, right, even within fraction of milliseconds, the optimizer identifies a best optimized plan for SQL server, I mean optimized plan for this query, right? For this simple query, optimizer will identify is a better plan, right? So it's not actually a better plan, it is a uh, like optimized plan. See here the statement, the goal of optimization, query optimization, is not to find the best execution plan, right? So it is to find a good enough execution plan. So there is a difference, right? So if it keep on searching for best plan, then it takes more time to so identify the plan. Instead of that, it will pick a good enough execution plan to execute this query, right? So that identified by the optimizer. So this is just so added execution and result set. So this is the same way. Optimization, once optimizer generate the plan, either it is a trivial plan or full optimization plan, then it will go for execution. So execute, sorry, so executor, query executor executes the query, then we get the query result set, right? So I'll just so show you how it looks like. For example, let's consider a simple query, right? So this is simple query, this is just simple query in adventure works. So I'm not using any joins or any conditions here. So this I will explain in detail, like so how to get, how to read the execution plan and all. Don't worry, for now just wanted to show you the difference between full optimization and the trivial plan, right? So I'm just executing this query. in AdventureWorks. So AdventureWorks, if you are not aware, so we get this AdventureWorks from so Microsoft free download. So you can download this AdventureWorks so you can play around. Right, so I'm executing this and we got some records like 290 records. And if you go to execution plan, so I have captured actual execution plan, right? So this is just to remember, this is just to show you what plan it is, right? So we are not going to discuss detail about the so icons we have. So this we call it as operator. So we are not going to discuss more in detail. So I just wanted to show you the plan, what plan it is. Just go to the properties of the select, right? So if you see here, right? So if you see here, the optimization level is trivial. So trivial is a simple query that we execute, right? So without any optimization, without any joins or without any conditions, constraints or anything. So it is just a simple select statement, right? It is going for, it is showing as a trivial, right? So trivial. And then if you execute this same with some joins, right? So if you execute this with some joins, right? So we have inner join. So I will explain these joins as well. So not logical joins. I will basically explain physical join operators when we talk about the query performance. So right. So it covers logical as well. So don't worry, I'll explain that. So if I execute this query, so we got some data, right? So based on this query, we got some records like 17 or something. And we see here, so some join condition and all. If you go properties of this, and if you see here, the optimization level is full, right? So the optimization level is full, right? So this is the difference between a full optimization and trivial plan. Trivial plan is simple, non-optimized execution plan, which is generated by the query optimizer. So it will not search, so thoroughly to get the plan. So it is just, so it picks the basic plan without any optimization, right? So when it go for optimization level, so it this diagram, if you remember, so these are the optimization levels. It will search for phase 0, phase 1, phase 2, like that. It will identify the plan. So if there is any join conditions or if there is any so constraints or any triggers or anything if you are using, so it will go for further level searching to optimize the query. So we do have so some trace flags. So I am not going to discuss much into, but if you use these trace flags, it will skip that optimization level. For example, this is undocumented. I'm not going to discuss much because we should not use these trace flags in the production. I'm just using the same query with this trace flag. So if you disable this trace flag, I mean, if you enable these trace flags, then we are basically disabling the trivial execution. If you see here, execute, and if you go here, properties, it is going for full optimization, right? So full optimization, then it is kind of, so not optimal for this query. So that is the reason query optimizer will go for normal plan, right? So if you see here, query optimizer will decide what to go. So you basically, if you force the optimizer to work as you need, then it might be good or it might be bad, but that has to be so taken care by either so performance team or developer team, right? This I will explain, like so how to enable for example, how to use option is to give a query hint, right? So we will discuss more about the query hints when we talk about the SQL Server, so query performance and tuning, and few of the query hints will improve the performance and few not, right? Yeah, this is just simple query to show you that optimization levels, right? So any questions? Okay, good. So this is the query life cycle of your simple select statement. So even if it is a so update query or any DML statements, the result set and execution and result set, everything will be the same, right? So only thing, if it is update or insert or delete, so you will not get any result set. Instead, you will see that the statement is completed or whatever it is. So we will be discussing more when we do any DML operations, how that works, right? So we are going to discuss that. So this is so simple, so I found this is interesting and good one, good, so to demonstrate the DML operations. Let's say you are a client, so whoever it is, and so doing some DML operations, right? Insert, update, or delete, whatever it is. So it is going through the same process, so network libraries, and it will be going through SQL Server to using TDS packets, right? So this is same as select TDS packets. It will be wrapping the SQL statement into so one or multiple TDS packets, and it will be sent to the protocol layer, right? So TDS packets, for your understanding, it is depends on the so packet size. For example, if the packet size is 4 KB, and the once the 4 KB is completely full, then it will send to the next protocol layer, right? So whatever packet size is full, or so which is required, so it will be sent to the protocol layer to get the data, to get and receive a so TDS packets. So from SQL network layer, so the TDS packet will be sent to the protocol layer at the SQL server, and then it will unwrap. So it will unzip or unwrap the TDS packets, and the language event will be sent to the command parser. This is same as select query. And once command parser, so validate that validate that syntactical errors, query binding, and verify whether the plan exists already in the plan cache or not. And if your plan is not there, then it generates a query tree and send it to the query optimizer, right? So query optimizer, again, the so it checks whether the trivial plan or any optimization levels, and it generates a plan tree, right? It generates a query plan. Once the plan is generated, then the plan will be stored in the plan cache, right? So saved in the plan cache for later usage. So until this query executed, so once this plan is generated, then it will go for query executor, and query executor will execute the query and need some data, right? So whenever, let's say, for example, you need to update some data, update, for example, let's say anything you can consider update, set business entity ID equal to 1000, where business entity ID equal to 100. For example, let's say you are going to update some data, right? So if you want to update, so how this update works, right? So how this update, so works. So simply it cannot be updated, right? It has to read some pages to update, right? So it has to read some pages. First, it has to read the data from wherever it is. If pages are not in the buffer pool, then it has to read from the disk, right? So it has to read the pages and update the value, whatever value it is, right? So likewise, if we are going to update, it has to read data from the storage engine. Then it connects to the storage engine through the OLEDB provider, right? This is a OLEDB is a communication channel or communicator between relational engine and the storage engine that we discussed until so access method. This is same for select or update or any DML operations or any operations, right? It connects to the access method, and access method has the some internal code to get, so it detects like how many pages we required to get the data, or how much how many reads it requires, or how much data it is required. So it has that information, right? So based on that, it will identify, or it will pass that information to the buffer manager. So this is the buffer manager that we have. Now this is the key point. So buffer manager, it checks the page is available or not, right? In where it checks the data cache. So this is the data cache we have. Buffer manager, it checks whether the data is available, or pages are available in the data cache or not. If pages are not available, then what will happen? So it connects the buffer manager, it read the pages from the disk. So that is where we have IO, input output, right? So input output, where it connects to the physical data file, right? Physical data file, and read the pages. Once read the pages, then those pages will be saved in the data cache, right? So these pages will be available in the data cache until we restart the SQL instance, or until we run a DBCC clean buffers or something, right? So until we restart the SQL instance, or until we have some issues that we will be talking, I'll just give you a high level overview when the pages will be removed from the cache. But yeah, so these pages will be stored in the memory, that is in our buffer pool, right? So once the pages are there, right, so the pages are available, then what will happen? What is the next? And we need to do some modification, right? So then that is where we have transaction manager come into the picture. So if you want to modify any data, especially DML operations, if you want to modify, let's consider it's a update statement. So there are mainly two operations, or two managers that is involved in updating. That is, one is lock manager and the log manager, right? That is under transaction manager. So whenever you modify anything, so first thing, it will be locking, right? It has to acquire some locks. If you so if you don't know, so every lock, it requires some amount of memory, right? So every lock, it requires some amount of memory that we will be talking when we go with memory, so memory and utilization and memory internals. But yeah, so it requires some memory to hold that lock, right? So I think it is very less memory, 2 KB or 2 MB memory it is required to hold a lock, right? So until that query executes, the memory will be locked. As soon as the query is released, or as soon as the query is completed, the memory will be released, right, to the SQL Server. This lock manager responsibility to hold a lock on the transaction, right, until the transaction is completed. So this lock manager will be for select query, even for DML operations, right? So locks also required for select. So that we will be talking when we talk about the locks. Select, we need shared lock, right? Or if there is any DML operation, we need exclusive lock, right? So it depends on what query we are executing. It needs a lock on the transaction. At the same time, so a latch will be acquired on the physical page. So what does it mean? Latch is a physical page protection. So physical page protection, for example, so if you're executing, for example, let's consider select. So if you execute select statement, sec. Okay, so if you execute select statement, it reads 9 pages, right? So it reads 9 pages to get the data. For example, let's consider, and latch acquires on these 9 pages to protect from another transaction or another query to acquire a latch or another query to modify these pages. For example, it is a select query, so shared latch will be acquired. Latch, what is latch? Latch is to so I would say, like, so a physical protection of your page, right? Protection of your physical page, which is there in the either memory or disk, right? So we have different types of latches. We will talk more later. So I will explain. So if the page is available in the memory, that is called page latch. When the page is not in the memory, we are reading from the disk, it will be page IO latch, right? So we will discuss more in detail, but for now, understand this lock manager will be taken care of the transactional locking and also latching of your data pages, right? Either the page in the buffer or either page in the data file, right? So we'll have a latch to protect our physical so page. For example, so if you are doing some update, so at the same time you are doing update, you are reading here, and if you are updating the same page, then so it is not consistent, right? So that is the reason you will have to wait. This is, I would say, like, this is sh latch, shared latch, and at the same time you are trying to use an exclusive latch. So this latch will wait until this is completed, right? So that is the reason you will not have so you will not have different latches acquired on the same page, right? So this will wait until this is completed. At the same time, lock also, this will wait until this is completed, right? So select query, update query, we would not be able to execute when there is a select or when there is a so any other incompatible locks or latches, right? So this is how the lock manager works. And coming to log manager, so what exactly log manager does? So what exactly log manager will do, right? So you are doing some modifications, right? So if you do any modifications, the log manager responsibility is to write the log buffer, right? Write the log buffer into the transactional log file first. What does it mean? So we are doing some update. Let's consider. So if you do update, what will happen? So will it write directly to the data page, or will it so would it does something else, right? So log manager, first it writes these logs, whatever the transaction we are performing, that will be written to the log cache within the same memory. So we have something called log cache. Log cache, right? So log cache. So that log cache will be written as soon as the transaction is committed, or the log cache will be written to the transaction log file if the log cache size is reached. For example, let's say it is a huge transaction and it is keep on writing, and the log cache size is around so 4 KB. Let's consider a small value like 4 KB or 4 MB, whatever it is. So let's consider this is a 4 KB or 512 KB, whatever it is you can consider. So log cache size. So we don't have exact visibility to check what is the size of log cache, but let's consider this is the size of log cache, right? Once this is reached, 4 KB is reached, then the log so that complete log cache will be flushed into the log file. Or if the transaction is committed, let's say log cache size is 1 KB for this transaction, and the transaction is committed. So it will not wait for this 4 KB to fill. So it will immediately flush into the log file, right? Transaction log file. So that will be taken care by the log writer thread. So we will be discussing more, so threads and scheduling in SQL OS going forward. So don't worry about it. But yeah, so log manager will responsibility to write the log cache from the memory to the transaction log file. So this will be written first to the transaction log file before even modify the page, right? So before even modify the data page, right? So this is what we call it as a durability, right? So what do you mean by durability? So durability is once the transaction is committed, so we will not lose the transaction at all, right? Or once the transaction is written to the data file, once the transaction is written to the log file, we will not lose the transaction if it is committed, or if it is uncommitted, so we will roll back the transaction. That we will talk, so I'm not going into recovery phases, but I'll just high level I'll talk, right? So what this process we called as write ahead logging. So what is write ahead logging? Writing into the transaction log file first before even write the data pages to the disk, or data before even writing the data pages, the modification before even writing into the data pages, it will write first into the transaction log file, right? So what is the advantage with that? Why we need write ahead logging concept even came into the picture, right? So why don't we write directly into the data file, right, or data pages? Because what if so that if we have written, but so let's consider the transaction is in the buffer pool. We have not written the transaction into the log file, so it is there in the buffer pool, but for some reason the SQL is crashed or SQL is restarted. So what happens to the modifications, or what happens to the transactions which are committed, right? So those will be lost, right? Because the buffer pool is a temporary work area where we store the data pages, right? So those should be either roll back or roll forward. So with the help of transaction log file, uh, so that is the reason write ahead logging is helpful in recovering your transaction, right? That is what log manager does, right? So log manager, it will write into the transaction log file before even writing those pages to the disk, when that is helpful, right? When that is helpful, let's consider a checkpoint. Let's consider a checkpoint. So so I will come to the checkpoint, right? So I need, anyone of you can tell, like, what is your understanding on the checkpoint, right? So what is your understanding on checkpoint, so that we will talk a little more on checkpoint and a lazy writer as well. Can anyone, what is your understanding of checkpoint, how that works, and how that is helpful to recover, so why we need checkpoint?
So yeah, the checkpoint is an internal operation from SQL Server engine.
Hmm.
So it will flush the committed transaction to the log file,
Hmm.
and also the same checkpoint will occur in buffer pool as well. So the dirty pages will flush to log file.
Data pages will flush to log file. Okay, okay, cool. So I think we have only 1 minute, it will be disconnected, so let's reconnect and we will discuss more. So whatever you said, that is correct, but some extent, so we'll discuss more, so what exactly the checkpoint and how that works, so whether that writes only committed, or so anything else it does in background, right? So let's I'll so I'll just disconnect, because we have anything, right?
Okay.
Yeah. So I'll just so give you a high level overview. Right. For example, as I told you, so the modifications. For example, it is an update, whatever, like so DML operations, and we are modifying that. So if we modify, right? So if we do any modifications, what log manager does? So log manager, it will write the transaction log, whatever the transactions from the data, from the log cache in the memory. So log cache to the transaction log file before we modify that data page, right? Before we modify the data page, right? Once this log manager return the transaction to the log file, then the buffer pool entry, like whatever pages in the buffer pool, will be modified, right? So if there is a checkpoint, but before checkpoint, yeah, whatever pages which are modified in the buffer pool, we call it as a dirty page, right? So what is dirty page? Dirty page is the page in the memory which is modified from last checkpoint, right? From last checkpoint, whatever modified pages in the buffer pool, we call it as a dirty page. Now, so whenever checkpoint happens, it does two things. One is it will write the log cache entries into the transaction log file. So it will write whatever pending log cache entries, it will be written to the transaction log file. First thing it will do that, right? It will write into the log cache, the log file, so that whenever there is a crash happens, so it can recover the transaction. Either the transaction is committed or uncommitted, it is secondary, but it will first write the transaction information into the transaction log file, right? That is first thing. Second thing, it will write whatever modified pages from the last checkpoint, or whatever dirty pages we have in the buffer pool, it will be written to the database file, right? Checkpoint does two things. One is it will write the whatever we have in the log cache to the log file, transaction log file, before writing these modified pages to the data file, right? So checkpoint does, it will write into the transaction log file, and it will flushes the data pages, dirty pages from buffer pool to the data file with respect to the transaction is committed or uncommitted. So we don't care like whether the transaction is committed or uncommitted, what will happen? So it will flush all modified pages from buffer pool to the data file. Also before that, it will write into the transaction log file whatever the transaction information, right? So that whenever there is a crash or restart of the SQL instance, it will scan the transaction log file to identify from where it has to recover. That is where we have recovery phases, right? So we have how many phases? We have four recovery phases. One is, so discovery phase, analysis phase, redo, and undo, right? So in discovery phase, so I'll just give you a high level overview. What is that? You must be knowing that. So, but yeah, today update, that is what update query is. So we have some time to discuss few points. So I am discussing some internals, right? So discovery phase, it will read through complete log file to identify the VLFs which has to be recovered, right? In discovery phase. Analysis phase, it will so identify the last checkpoint. From there it will so it will create a recovery point, right? So it will create internally the TPS table and active transaction table to recover your transaction. So in the TPS table, what it contains, so what data or what pages we need to roll forward, that is writing into the data file. So in active transaction table, whatever transactions which are not committed at the time of crash, so those will be rolled back, right? So where the checkpoint information will be written. So how the checkpoint information will be written? There are two places the checkpoint information will be written. One is transaction log file. Second one is database boot page, right? So I'm not going into pages and all, but we have a main database page, that is boot page, where the checkpoint information will be written to the boot page. whenever database is started, so it will scan the boot page and identify the checkpoint LSN. From there, it will determine from where the data has to be, so recovered. The transaction has to be recovered. In simple words, checkpoint is a writing data page, a dirty pages from buffer pool to the disk. Also writing transaction information from log cache to the data log file, log cache to the log file, right? So when this page, we said like, so it is dirty, right? When this place will be clean, so the place will be clean, or so when there is a checkpoint, if the checkpoint happens, the page will be flushed to the data file, right? Then the page, we call it as a clean page. It is not no more dirty, because whatever modifications it is there in the data file. So it considered only dirty when this page is different than the data file page, right? For example, data file page is 100, and you copy this page, or buffer manager copies this page 100 here, and you does some modifications and you modify it to 110. This is called dirty, right? So we modified some data. This is called dirty. And as soon as you checkpoint happens, this page will be flushed to the data file. So you will have this 110 here as well, and 110 here as well. If both are same, then we don't, we never call this as a dirty, because the checkpoint is written the page from the buffer pool to the disk. So it is, in a simple words, checkpoint is just copy the pages, copy. So don't use this word, but so just I'm telling you for the sake of simplicity. So you just consider this as copying pages, modified pages from buffer pool to the disk. So what is lazy writer? So what does lazy writer do? So if there is any so memory pressures, right? If there is any memory pressure, so it will check, so some algorithm it will follow. So that is LRU algorithm, least recently used algorithm. It will flushes or remove. So in other words, you can consider this as a cut and paste into the data file, right? Checkpoint is just a copying pages from buffer pool to the disk. Lazy writer, it will cut pages from the buffer pool. That is the reason it will clear some memory. If there is a lazy writer, so happens, so it will remove the pages from the buffer pool, so that the memory will be cleared and it will be flashed to the data file, right? It depends on least recently used. For example, my page is so 10 minutes or 10 seconds, and the page is 1 second, and which is currently in use, right? So it will be used, it will be removed this 10 seconds, so whenever it was last used, right? If it is not recently used, then this will be removed from the buffer pool and returned to the database file. So is it clear how that works? So checkpoint and lazy writer. So any questions so far, right? So the update query, so that happens, and so any questions on update or anything on checkpoint or lazy writer?
Chindu, ledger writer can explain also this.
Sure. Yeah, sure. So we will talk more, so when we talk about the memory, so, but I'll just explain lazy writer. So checkpoint clear. Checkpoint, I'll just give you again high level overview. Checkpoint is writing into the transaction log whenever checkpoint happens. So there are different types of checkpoints, right? So if you are not aware, just read through the books online. So we have different types of checkpoint. One is automatic checkpoint, manual checkpoint, indirect checkpoint, and indirect checkpoint, and auto, yeah, so there are two things: automatic checkpoint and auto checkpoint. Auto checkpoint is every 60 seconds. Automatic checkpoint is based on recovery interval. recovery interval, it will keep on executing the checkpoint, so internally, right? We can define that sp underscore configure. So that will define, like, so how frequently we need to execute, we need the checkpoint to be run, right? So indirect checkpoint is target recovery time. That is also sp underscore configure. Well, I'll just show you if you, so you must be aware, but sp underscore configure, that is the advanced, sorry, so that is the advanced option. So recovery interval, this is the automatic checkpoint, and we should have target recovery time is the, okay, so I think this is option. Target recovery time is, by default it is 60 for from 2016 and onwards. You can, so let's have 80, right? Set target recovery time. So database configuration, so we can set the so indirect checkpoint for individual databases, right? So this is indirect checkpoint for individual databases. This is at the instance level, automatic checkpoint. So it happens frequently to flush the data pages to the disk, right? That is checkpoint. So lazy writer, so what exactly it does, let's say there is a memory pressure. So memory pressure, I mean, so I will discuss more in memory, but for now understand that there is a memory required for SQL Server, or memory required, so let me consider this simple term. Max server memory, right? So you consider max server memory as 1 GB, let's consider, right? So then you have a database size, DB size is 2 GB, let's consider, right? So you have a 2 GB database and you have max server memory is 1 GB, right? So you are doing some, so huge operation, either select, update, whatever it is you are doing. So you need to read almost all the pages. Let's say, for example, you want to read 1.5 GB data pages, right? So you need 1.5 GB data pages. So you have just read, so 1 GB data, 1 GB, and it is almost reached. The max memory is reached because you have 1 GB, right? So that is reached. What about remaining 500 MB? 500 MB data is left over. So we cannot read because the max server memory limit is reached. Then what will happen? SQL internally detects there is a memory required for this 500 MB pages to be placed in the memory. Then the lazy writer SQL memory manager. So internally it will ask all its memory, so clerk. So I'll not go into that, but SQL Server internally ask everyone to reduce their memory. So buffer pool will be monitored by the lazy writer. So buffer pool will be monitored by the lazy writer. So it invokes and it checks if the memory limit is reached. So it is a continuous operation. It is not kind of, so it will suddenly wake up and it checks. It is not that way. It will check continuously whether the memory limit is reached or not. Whatever max server memory we set is reached or not. So this lazy writer, it keeps on checking for max server memory limit, and it detects that max server memory is reached. Once it is reached, it will cut down the pages. What does it mean by cut down the pages? Whatever pages which are not recently used, LRU, right? Least recently used. Whatever pages which are not recently used, those pages will be removed from the buffer pool and write into the data file. So these pages will be removed and right into the data file. So if it is not recently used, and these will be removed from the buffer pool to the data file, so that it will clear some memory. Let's say, for example, 200 MB, it is cleared. 200 MB, it is cleared. If it is cleared 200 MB, then we can place 200 MB pages here, right? So if it is already, if it is reached, again it checks if there is any other pages I can remove which are not recently used. Then it will remove those pages and it will be moved to the data file. So though the pages are in use, if it is needed, then it will be removed from the buffer pool and it will be right into the data file. Right, it will keep on doing that if the pages are if the pages are currently in use. Let's say, for example, these pages are in use, it will be flushed to the data file. When these pages are need, it will be read again from the data file to the buffer pool. So it is kind of removing that. So if the pages are in use, maybe we have an option to increase the max error memory so that these pages will not be removed and it will not be read from the disk, right? So lazy writer is a process of removing the pages from buffer pool to clear some memory in the buffer pool, to clear some memory for SQL Server to store some more pages or to release memory to the OS. Let's say another example is OS. Operating system needs some additional memory. So additional memory, if it needs, we need to remove from the SQL Server, right? So SQL Server is using most of the memory. Then it will be removed and it will be, so the memory will be reduced and it will be released to the operating system. So that is, we will talk more, so how that works, like max error memory, min error memory, and let's say, for example, OS needs memory. If OS needs memory, why my SQL Server should remove memory from the disk, from the memory, from the buffer pool, right? I don't want SQL to be released. So we do have some options. We will not, so release our SQL memory. That option I will discuss more in detail. So is it clear, like lazy writer and checkpoint? Is it clear?
Question.
Cool.
Yes.
Yeah,
Thank
cool.
you.
Right. So I think I am done with the update statements. So one more, so I will just, thought of telling that. So you must have heard delayed durability, right? So can someone heard that? I mean, so did you guys heard delayed durability, or what is delayed durability? What is durability? Let's consider this as a so interactive session so that you will have so better understanding of internals and how that works. But maybe it is useful for you to attend interviews as well. Yeah, someone.
Yeah, it's one of the type and ACID properties.
Hmm.
So simple example, you are recording the session.
Hmm.
Even if you need, we can see it from the recording session. That's a simple example for the durability.
But how that is helpful for SQL Server?
SQL Server, for example, if the data has been lost as a power cut, something like that, then data will be retrieved from, but the data will not be flushed from the data file or transaction file.
Okay. Yeah, so whatever you said, that is seems to be correct. But yeah, so for just so high level, what is durability? As you mentioned, like it is a last property of acid atomicity, consistency, isolation, and durability. So durability is once the transaction is committed, so it will be available even if the system is crashed or database is crashed, or so even if there is any restart happen, anything, that transaction will not be, so whatever committed transaction will not loss, right? So that is what a main purpose of durability is. Once the transaction is committed, then the transaction or whatever committed transaction will not be lost even if there is any system crash, right? So what, like how the logs will be flushed? So log cache will be flushed. So I'll just give you a overview. Right, let's say consider this log cache. So what is log cache? Whatever transactions we are writing into the, I mean, whatever, if we do any DML operations, it will be writing that information to the log file, log cache first. So log cache. So from log cache, it will be written to the transaction log file. That is your LDF file, right? So whatever modifications we are doing, so it will be written to the transaction, it will be written to the log cache first, which is there in the memory, and a separate log writer thread. So don't worry, we will discuss about the threads. For now, understand this is one of the worker, one of the thread that it is writing log cache to the log file, right? So while when this log cache data will be written to the log file, I told you two scenarios. So one is when the transaction is committed. So if the transaction is committed, then this will be written log cache in whatever size with respect to the size of the log cache, it will be written to the log file. Second, when the buffer in log cache, when the size of the buffer size in the log cache is reached, let's say buffer cache is 4 KB. If it is 4 KB reached with respect to the transaction is committed or not committed, it will be written to the log file, the whole buffer, complete buffer, right? So it will be written to the transaction log file. Let's take a scenario. We are using temp transactions or small, so transactions. It is frequently committed. For example, let's say insert. So insert. So you are doing some insert, like huge inserts, right? It is immediately commit. So if it is immediately commit, what will happen? It is keep on writing into the transaction log file. As soon as this transaction is committed, it is keep on writing into the transaction log file. So what will happen? So the log file is very busy, right? So it is keep on writing into the transaction log file as soon as the transaction is committed. If it is a small transaction, for example, let's say insert into test values 1 comma ABC. Let's say this is a small transaction. So as soon as this is committed, I'm not going into the so the transaction, the transaction types. So we have multiple transaction types, right? Implicit transaction, auto commit transaction, and explicit transaction. I'm not going into that. So this is a auto commit transaction. So it is, so auto commit transaction. As soon as the transaction is completed, the transaction will be committed. If this is committed, what will happen? It will write immediately to the log file. This is committed, it will write immediately to the log file. It is committed, it will write immediately to the log file. If that is the case, every time we are trying to write and so doing every insert or every modification, we are keep on writing into the log file, the LDF location or LDF file is very busy, and you will see some delay in performance, right? So you will see some performance issues. Instead of that, I don't want every transaction to be written to the transaction log file immediately as soon as it is committed. Instead, I will write once the limit is reached. Let's say it is 4 KB. Once this is reached, then only I should write into the transaction log file. Then you'll have to enable delay durability. So delay durability option, what it does, it will delay writing into the transaction log file. It will be delayed writing into the transaction log file. right? So instead of writing each and every transaction once it is committed, it will wait for this 4 KB, so whatever size is reached, then the transaction or log buffer will be written to the log file, right? So that is how the delayed durability works, right? So this is, so out of this so topic, but just wanted to let you know so that you understand in a better way how the transactions information will be written to the transaction log file. So we are basically so delaying a committed information written to the transaction log file, right? So this will reduce the load onto the LDF file, right? So you must have heard, so wait type as write log, right? Write log wait type. So write log write type is this. Whenever you are writing into the transaction log file, this is the wait type it will be waiting on. If you see high number of write log wait types, so this is one of the reasons that you are keep on writing into the transaction log file as soon as the commit is happen, right? So just to avoid this, maybe you can consider the delayed durability, or you'll have to understand why we are keep on writing into the transaction log file. But we will discuss more detail about wait types when we talk about the wait types we have on major wait types in SQL Server. Right? Hope this is helpful. So any questions on any of the process like yesterday's or today's or whatever points we discussed, like checkpoint let you write a delayed durability or anything? So I will stop here. So if you have any questions, we will discuss, and so we will continue next class. I will let you know, say either tomorrow or so either tomorrow or Monday. But yeah, so you have any questions, you can reach out. You can ask me here now.
Yeah, Chandu, so for how the driver will work on optimization here for the update.
So update query, so the trivial plan. So optimization, so if it is a simple query, so that is the same thing. Like, so even it is a select query or update query, so it will check internally, like, so either it needs how many tables we need to retrieve to update the table, update the data, right? So it can be a single table or it can be multiple table, but it will check what is needs to be updated, how many records we are going to update, and how many how many pages we need to read to update that. So mostly I never see that update is a trivial. Mostly it is a select is a trivial, but so even update also can optimizer will choose whether it go for so full optimization or trivial. So based on that, but definitely it will go for so my understanding is it will go for trivial if you are using any indexes. Let's say we have indexes and it has to scan the index to update some data, right? So how update works, it has to read pages and then it identifies which page needs to be updated. If we have a index on that page, so then it will either go for seek or scan based on the index we have. Then the update will be updated, like whatever data we will be, it will be updated to that particular page. If we don't have an index, so we need just so we will be reading the complete table or complete so all the pages, and it will be updating. So if you are not using any of the indexes, it might go for trivial plan, or if it needs to read multiple tables to get the data to be updated, then it go for full optimization. If we have a indexes, or it like say for example, as I told you, right? For example, let's say the update query, the cost is, how would I say? Yeah, cost is more than the cost threshold for parallelism. So because those terminology I have not explained, so I was not, so more comfort in talking. But let's say consider cost threshold for parallelism set to 50 or 20, or by default it will be 5. If update query is reached that limit, then it go for full optimization. Then it go for parallel execution, parallel, so query and all, multiple threads and executing that full optimization, right? So it so derives multiple level of optimization to go, either it is a trivial or full optimization. So it based on various factors like, so indexes, cost of the operator, cost of the query, and so how many tables and how many pages we are reading, how much data we are retrieving. So we will be doing that. Let's see. Let's see if I get any, sorry. See, so even though it is a small, so it is going for multiple queries, right? So for example, let's say you are doing something and you are executing this, right? So, okay, where is that? Reconfigure configuration, okay. Business entity equal to 200. Something is not updating, but yeah. So if you do, for example, let's say estimated plan, right? So even though it is a small table, so it read through multiple joins and all to get the data, right? So because it has to read, so multiple, though in a single table, it has to read through multiple, so pages and multiple columns and all. So that is the reason it is going for loop join and all. So it has to read indexes and all. So based on this, it is going for optimization. See here, this is, even though it is a small simple select query, it is going for update, right? If you use this, so this is also going for full optimization. So I never see that. That is the reason I never see that update query is going for trivial plan. So mostly select query is going for trivial plan. So update query mostly it is going for so full optimization, because it has to do so two things. One is it has to read the page. Select query, it has to so how update works, and basically, so it will read the data, then it will delete the data, then it will insert, right? So selecting, deleting and inserting, right? That is how the update works internally, but that we will not discuss more. But that is the reason we don't see the update queries going for trivial plan, right? Is that clear? Did I answer your question?
Yes, Chan.
Okay, cool. So any questions?
Hello, hi Chandu.
Yeah.
The small question, Chandu.
Yeah.
When 10 transactions are updating, so the 10 transactions first will be done in buffer cache, right?
Correct.
I think buffer cache. After buffer cache, it will goes to the log file.
Correct.
In log file, information is recorded, or that same transaction also data also will be placed.
So
The 10 transactions.
transactional, yeah. So transactional log file. So you will not have the exact, so data or something. So you will have the transaction information, like either it is, so either update or insert. So that information will be written in the transaction log file. So you will not
Only
have
information, no data will be there in the log file.
No.
Only information will be there.
Correct.
And after committing the data, it will flush to the data file.
Once the transaction is committed, so still it will write into the transaction log file. At the same time, the pages will be written to the data file once the transaction checkpoint happens, not commit. So if you commit, so the page will not be written to the data file. It is still there in the buffer pool. Once the checkpoint happens, that is the only point where data will be written to the data file. Pages will be written to the data file.
Yeah, that the data won't be there in the log file. Only information will
data
be
will be there in the log file. No? So data will be there in the log file until and unless you truncate the log file. So it is still available. Okay. Yeah. So whatever transactions we are doing, so it's still available in the VLFs or transaction log file. So only will not be available if you truncate the VLFs. When this will be
okay.
truncated, then if it is full backup, full recovery, then you'll have to take a log backup, or if it is simple recovery, then there is a limit like 70% or 80%, then it will be truncated the transaction log file.
Yeah,
But if
okay,
the
okay. That
transaction
means
is committed, then only you can truncate that, right?
so only complete only then will truncate. That
Correct.
means the data is available in buffer cache as well as the log file. Both
Log
we
file.
are having the data.